first of all, why is OpenTelemetry exciting now? And I think the answer to that comes back to how the practice of software engineering has changed so dramatically over my career. So today, if I want to start coding, I want to create a web application, I can go to Glitch, and in 20 seconds, I can get a Node.js server and my own domain, and I can expose that to the world. And that's pretty amazing. And all I have to think about is the code. And then if I want to scale it, I can use something like Google Cloud Functions, and I can get almost limitless scale. And I still only have to think about the code. And then if I want to optimize end user performance and be within 20 milliseconds of almost everyone on Earth, then I can use Fastly. And all of these things are very easy for me to adopt whilst still focusing primarily on the code of my application. So the times from when I had to worry about, racking servers and installing operating systems and patching servers have all kind of gone away. And so now I have almost limitless options for what I can do with the code. We've gone from, virtualization systems to gradually abstracting all this stuff away by adopting things like infrastructure as a service, and then platforms as a service, and then functions as a service. And now we have this kind of nirvana where we only have to focus on the code that we're writing. And the flexibility and freedom that this opens up gives us the opportunity to run that code in more places. So we can now think about running code not just on our cloud platform, but also on edge platforms, maybe more than one edge platform, as well as the device in the end user's hand as well. And this creates a kind of pipeline with a trade-off effect between the amount of visibility of scope that you have, of state that you have. At the core of your system, you have a view of the complete global state, but you're far away from the end user. And in the end user's hand, you have the best performance, but you can only see the local state. And you could run different code in all these places, or you could run the same code in all these places. It's the freedom and flexibility that comes from being able to use these kind of serverless technologies is pretty amazing. And we even have things like software as a service now, so that, if you're like me and you've written probably upwards of 3 content management systems in your career, you definitely don't want to write another one. And being able to use SaaS products as part of our systems architecture helps us to avoid reinventing the wheel. So if you're on this train and you're doing all of these things, then you probably have a systems architecture diagram somewhere in your organization that looks a bit like this. And this is great most of the time, but then you start to realize some of the shortcomings. And then, you start to see all of these kind of microservices memes and realize that when something goes wrong in one of these services that's part of this massively distributed service-oriented architecture, you really have no idea where the problem is. And that's why I want to talk about OpenTelemetry and why I'm excited about OpenTelemetry, because it is a technology that is uniquely designed for modern software architectures that are distributed, and therefore is really uniquely suited to Fastly. So let's think of a systems architecture that includes Fastly and a browser front end that's running React.js, and an origin architecture that includes a gateway service and then some SaaS services that it's reaching out to behind that. So a fairly straightforward architecture, which nevertheless includes quite a number of components. Now, when an end user makes a request from the browser to load a page, for example, that transaction might touch all of these services. And so what we really want to be able to do is visualize that in a trace, which ideally looks something like this. And the magic of distributed tracing is that we can construct one single visualization of this user's journey through the system. And this visualization can include multiple different technologies running on different platforms by different vendors. So here you can see that this request has been processed by Fastly and LCY, and then it's been passed to IAD, and then it's been sent to a Google App Engine application, That has then made multiple microservice requests to a profile data service, a flag service, add data, articles, and partner content. And then it's presumably assembled the responses from those requests and sent them back to the user. This kind of trace is really powerful. And in fact, in this particular one, you can identify immediately there's a performance problem with the partner content API. And it's this long request here that is causing ultimately the response to the end user to be slow. If we didn't have a trace like this, it would be very hard for us to figure out that this particular part of the system is the one that's causing the performance problem. Because this is open source and because it's an interoperable standard, I don't have to use any one visualization tool to display that trace. So that first one that I showed you, this is being visualized by Honeycomb.io, which is a commercial SaaS product that provides analysis tools for traces. This is Zipkin, which is a locally installable open source trace visualizer. And this is exactly the same trace. So I can take the same trace data that has been generated by any system running any technology that is compatible with the OpenTelemetry standard, and then have it interpreted by any analysis tool that understands OpenTelemetry. And I love this because I'm a standards nerd and I love standards that work and enable these kind of disconnected systems to talk to each other and work effectively together. Because it reminds me of Adium, which is this brilliant tool that used to exist for the Mac, where I used to have all my friends in one list. And I could even put them in group chats. I've no idea how that worked. Today I have this, which is terrible, and I hate it. And I don't know why we have to put all of our, why we have to evolve all of our software applications into walled gardens. But OpenTelemetry is different, and it's a fantastic effort by the industry to create a genuinely interoperable standard, and I love it. Now, the bit of this trace, the first bit of this trace I want to focus on is the bit where we transition from Fastly to Google and where we change color. This indicates we're crossing a system boundary. Now, how do we propagate the context from Fastly to Google to tell Google that whatever it does, it needs to attach to this point in the, this parent point in the trace? We do that using something called trace context. And this is really a fancy way of just describing an HTTP header that's called trace parent. I don't recommend typing the word trace parent into a Google Doc. It will automatically change it to transparent because it's completely convinced that you've made a typo. So if any part of this presentation includes the word transparent, I almost certainly meant to type trace parent. The header contains the ID of the trace, and it also contains the ID of the parent span. And this is important because it tells the system that's receiving this request that it's not the first system to interact with this transaction, and it needs to report this span ID if it generates any tracing data of its own. And this enables us to take these fragments of trace data and assemble them into this tree where we can see the path that the request has taken through all of these different systems. So let's look at some code. So OpenTelemetry is a pretty mature project, and it has developed abstractions for a lot of technologies and platforms. So Node.js has some pretty mature OpenTelemetry libraries available. This looks like a pretty intimidating set of code, but actually it's just OpenTelemetry's practice of breaking everything down into small modules. So effectively, you have a few important things here. The trace exporter, for example, tells OpenTelemetry where to send your telemetry data. The span processor tells it how to batch the data together. So whether to hold a number of traces and then send them all at once, or whether to send them one by one. And the other really important thing is the instrumentations. So one of the magic things about OpenTelemetry is it comes with a lot of automatic instrumentations. And that means you don't have to define the start and end of each operation yourself. The libraries will do that for you, especially if you're using a framework that OpenTelemetry has plugins for. So for example, if you're using Node.js, common frameworks include things like Express, Happy, Fastify. these are frameworks that effectively create web servers. You can create handlers, and you can process requests to certain URL paths. If you do that, and if OpenTelemetry knows about your framework, then it will create spans automatically for the requests that your server receives. And that's pretty cool, because it means you effectively get tracing for free. In the browser, it's a very similar situation. The main difference with the browser is that async context propagation is a bit more difficult, and you need a library to handle that specifically. But OpenTelemetry has one that you can just use, and it works. The other thing I did when I used OpenTelemetry in the browser was I modified the standard instrumentation slightly so that the fetch API, which in JavaScript in the browser allows you to make HTTP requests to your API, I wanted to report the status, the HTTP status, and the method of each of those calls. So it's quite straightforward to take a standard instrumentation and to modify it slightly to add extra data. So can we do OpenTelemetry on Fastly? Well, absolutely. We've written an OpenTelemetry library for Computer Edge, which interacts with our JavaScript SDK, and it even comes with automatic instrumentations. So it will instrument the request handler that handles the event from the client. And of course, you can also add your own instrumentations too. And this was written by Katz Amoro, and we've already seen a number of customers using it, and also customers asking us for Rust implementations as well. Can we do it in VCL? Yes, of course we can do it in VCL. You can do anything in VCL, as long as you write the raw OpenTelemetry protocol in a log statement. Which might look like it's terrifying, but actually I really like this because it enabled me to learn a lot about the OpenTelemetry data model. Most of your interactions with OpenTelemetry will be through libraries and through abstractions, and it does somewhat obscure the ultimate model that OpenTelemetry uses. Whereas in VCL, you don't get any of that. You just have to write the protocol yourself. And it actually helped me to understand OpenTelemetry quite well. It reminded me of when I was first learning HTTP, and I would use Telnet to open a port 80 to a server and just type HTTP down the pipe and get the server to respond to me. So it just helps you to learn the protocol. Okay, so let's talk about custom spans. Everything so far has been automatic instrumentation, but at some point you're going to want to say, I have an operation that starts here and ends here, and I want it to appear in my trace. Here's an example in that trace I showed you earlier, where that microservices router is creating spans around each of the fetches it's doing to its backend microservices, this one called profile data. So to do this, we use the OpenTelemetry API to get hold of a tracer, and then we use that tracer to start a span. And then you can call end on the span itself when you're ready to say this span is finished. Now, spans by themselves don't create context, and context is what creates the hierarchy. So if you create a span and then you start doing work, and then inside of that work, you create another span, that span will be a sibling of the span, the first span you created. It won't be a child. In order for it to be a child, you need to also change the current active context. So in this piece of code, we're doing both of those things. We're creating a child span, and then we're changing the OpenTelemetry context to the context of the child span. And that means that if any spans are created during this heavy duty work, those will be attached to the child span. Why is this important? I mean, we might know for sure that in this heavy duty work, we are not going to create any more spans. So why does it matter that we change the context? It matters because of library spans. So most software engineering is done using dependencies, right? You're going to use a lot of code that you didn't write yourself. And when you install those dependencies, import them and use them, you don't actually know, unless you read every line of code, what that dependency does and how it's implemented. And you don't know whether that dependency might be instrumented using OpenTelemetry. Except you do know if you've got an OpenTelemetry configuration in your application, because your dependency will just start emitting telemetry like magic. And so if you set your context correctly for every part of your application, then any spans that are just emitted by dependencies that you're using in your code will attach themselves to your trace at the right point. Now, your application is also going to make requests to some other services, and we need to forward that trace context to those other systems so that they can attach their spans at the right point in your tree. And to do that, we need to use a trace context propagator, which is a really fancy way of saying we're going to make an HTTP header with a trace parent value. And in OpenTelemetry parlance, they call this a carrier, but it's really just the value of the trace parent header, which we can then pass into a standard interface like fetch to add that header to our HTTP request. And then if the receiving system also uses an OpenTelemetry library, it should recognize that trace parent header and automatically use it for any spans created in that system. What about the front end? So I experimented with instrumenting Fastly Fiddle, fiddle.fastly.dev. Hopefully some people have used it. It helps to simulate Fastly services and allows customers to debug problems that they might have with their VCL or their computer edge code. And this is a React application, so we should be able to instrument this. So I added instrumentation to it. I also worked with Greg Burek and the observability team. Thank you very much to them for all the help. And this is our own observability tooling. This is Tempo in Grafana visualizing a trace which I've recorded from Fiddle. And the cool thing about this is you can see that this is a very, very long operation. It's an operation that takes almost a minute. It's a complete Fiddle execution. So this is a very custom defined trace. You know, it's not just one request from the browser to the server. It actually covers multiple requests from the browser to the server. It includes some very long running streamed responses. And it allows me to be very precise about what I define to be one operation. Also, you can see three separate systems in here. The green spans are coming from my React.js front end. The orange spans are coming from my Fastly service. And the blue spans are coming from my Node.js application, which is running Fiddle on the server side. And I could add more things in here as well. I also love the idea that, you know, these operations here where the Fiddle app is talking to the Fastly API, we could actually we could pass trace context to the Fastly API and actually see what's going on, like beyond the boundary of the Fastly API, if it allowed me to tell it where to send the telemetry. But front end in general is quite hard to observe. It's noisy. We can't necessarily trust any data that we receive from the client. And OpenTelemetry libraries are not really designed for relaying telemetry. It's designed to go directly to an OpenTelemetry collector. So this is actually a really good use case for Fastly. So I put Fastly in front of an OpenTelemetry collector, and this allows me to do some basic authentication, to do some rate limiting, to validate the syntax of the submissions, throw away anything that doesn't look like an OpenTelemetry trace. So where does the telemetry ultimately go? So your code interacts with the OpenTelemetry API, and an OpenTelemetry configuration within your application will forward that collected data to an OpenTelemetry collector, which then ultimately exports it to a store. You can have lots of collectors. You can have a collector that sits next to your application. You can have one that aggregates data regionally, maybe if you're operating at a very large scale. You can have one that aggregates globally. These collectors could cut down your data to sample to reduce the amount of data you have to collect centrally. They can validate, they can add extra annotations to the data. They're pretty flexible about what they do. This separation between the OpenTelemetry configuration and the OpenTelemetry API within your application is really important, because the OpenTelemetry API is a shim. It doesn't actually do anything. That's important because of those library spans that I showed you earlier on. You could create a library that you ship to, like, as an NPM module, for example, and you could include OpenTelemetry telemetry in it. And if the person that consumes your library doesn't have an OpenTelemetry configuration in their app, then it just won't do anything. It's the existence of an OpenTelemetry configuration alongside the code using the OpenTelemetry API that will actually activate that observability. And then in the collectors have effectively three parts to them. There are receivers that can receive data in various different formats. There are processors that are executed in turn in a pipeline to process the data that you are pushing into the collector, and exporters to then forward that data on in whatever format you want to somewhere else, like Honeycomb or Zipkin or Jaeger, New Relic, wherever you're collecting your telemetry data. There are a few buts. Things that I found were a bit problematic about OpenTelemetry. So the first one is span events. Span events are things that happen at a moment in time that have certain data attached to them. And that sounds a lot like logging, because it is logging. But the thing is, observability, in the theory of observability is that there are three pillars: traces, metrics, and logs. And OpenTelemetry does define a standard for logging, but it doesn't interact with the standard for tracing. So the trace standard actually has a concept of span events. And that feels messy to me. It feels like we don't really need span events and logs. So I feel like that's slightly annoying. And secondly, what I found was that sometimes when I forwarded trace context from one system to another, the trace parent header would get mutated by the platform that was hosting my application. So both Google App Engine and also Glitch actually were both doing this. I would receive a trace parent header that had a different span ID to the one that I knew that I was sending. And that's because the platform on which I'm running my application is actually instrumenting itself. And so there is a span being created that I can't see. And that is really annoying because it means that effectively you get a branch that's broken off your observability tree. And if you send your data to something like Honeycomb or Zipkin or New Relic, they'll render a tree, but they'll show you that you have a branch missing and it doesn't know where to attach this piece of telemetry data. So I fixed this by renaming the header to X trace parent, which is not a great solution, but it does work. There's also lots of boilerplate code, especially in situations where you want to create custom spans and you also want to change the context and you also want to provide some custom span data. So I wrote an abstraction that allows me to do all of those things at once. So now I can just wrap whatever I want to do in a function called trace span. I can provide the name of the tracer, the name of the span, any additional properties that I want to attach to the span, and then an async function in which I execute the work of the span. One thing I really loved about this was that once I wrote this function, I could use it in Node.js, I could use it in the browser, and it also works on Computer Edge as well. So that same piece of code is running on 3 different platforms. That's pretty amazing. So in summary, OpenTelemetry is pretty cool. It's a really huge effort, but I really love the ambition, and I think it's already very usable. It provides amazing visibility. I fixed several problems in Fiddle just by using it as a kind of test bed for trying out OpenTelemetry. And it supports a ton of languages and frameworks. If there's a language you use to write applications in, it probably has OpenTelemetry libraries for it. And it's all free and open source. Some problems: it's pretty intense to go beyond the basics right now. That some of the examples that you'll find on the OpenTelemetry website make it look very simple, but then you think, but how do I do X? And then you find that actually that's really quite complicated. And like I said, the logs, metrics, and traces elements of OpenTelemetry are not as joined up as I think they could be, and are definitely intended to be in the future. And obviously, cloud platforms like messing up your trace context propagation is really not great. But on balance, I think it's well worth looking into OpenTelemetry if you're doing any work with observability tooling. All of these kinks are likely to get worked out, and tools like Honeycomb, Datadog, Lightstep, Zipkin, Jaeger, they're all very, very good, and they get better all the time. And this is the key point for me. You can already feel like edge applications like Fastly are just part of your application architecture. The way I like to discuss this with customers is to say the way that you think of Fastly shouldn't be that you have your systems architecture, this complicated diagram with all these boxes and arrows, and then you put Fastly in front of it. What we want you to think of Fastly as just one of those boxes on that diagram with all the arrows pointing at things, because then it feels like we are just part of the system, not something that sits outside of it. And observability is a really key part of that. So that is all I have. And I don't know whether I have time for any questions, but if I do, Tom has one.
I do. Long-time listener, first-time caller. I'm curious about that trace parent issue where the span was missing the parent because the platform you were sending it to was probably instrumenting itself and then replaced the trace parent header that came in. Is that a problem with the specification itself, such that the platform didn't implement it correctly, or does the specification allow for that? And is there a way to nest spans from multiple? You know what I'm saying?
So I don't think it's technically wrong for the platform to record a span. What is probably less good is that it does it automatically and doesn't let me opt in. And also that it doesn't let me control where that the trace data goes. So Google Cloud Platform, for example, is sending that trace data to Cloud Tracing, which is its own tracing tool. And that I don't like that, because I have my choices of where I want to send my trace data. I want to send it to my OpenTelemetry collector. I can configure Cloud Tracing to do that, but this is unnecessary wiring. If that span was not being collected in the first place, I wouldn't need to do that.
Okay, so in order to get those traces out of Google, you would have to configure that. And when the glitch case, for example, that's like our own telemetry that we probably don't allow people to configure, and so there's like a bug.
Yes.
Yeah. Okay. Thanks.
Also, we could potentially, the standard could potentially fix this by including all prior span IDs in the trace parent header. So if the trace context propagator contained every ancestor span, then you wouldn't have this problem, because you'd be able to say, okay, there's a missing span here, but we know what its ancestor was, so we can still render the tree correctly. Whereas the standard doesn't allow for that. It assumes that you have perfect knowledge.
Yeah, it's a linked list and it needs to be a full tree.
Right.
All right. Thank you for this talk. It was very good.
You're welcome. Oh, we have a question in the room. Yeah, interesting question. So I don't know whether the audio caught that, so I'll repeat it. The function that I wrote, my trace span function, should that just be part of OpenTelemetry, telemetry's own libraries? Interestingly, the answer to that is probably not, because according to the OpenTelemetry website that I read, they actually advised as a best practice to not do what I did. Like, it seems like, but I think that advice is kind of targeting a slightly larger scale deployment of OpenTelemetry. Like, on a small scale, I think it's fine to sort of wrap up a bunch of these telemetry things into a sort of utility function, make a bunch of assumptions, and then just make the interface a lot easier. I think what they're getting at, though, is they're basically saying, if you do that, then the way that you use the interfaces is going to ossify to some extent, and also you're going to use some of these properties incorrectly because you'll just set them all to be the same. Like, for example, in my case, I don't use the same tracer instance each time. I just generate a new one each time because it's easier. And you're not technically supposed to do that. So there are definitely disadvantages to like abstracting the problem away, because you get less detail.